Hello guys, once again I am in front of you to teach you about probable error. Okay, so especially for BBS first year student, BBA third year, BBM and BIM third year, and BCA also third semester. Okay, not year, semester. BBA third semester, BIM third semester, and BBM third semester. Students, this is very helpful. Probable error. Probable error is the reliability of coefficient of correlation. Carl Pearson coefficient of correlation value ranges from -1 to +1. And what value we observe, whether that value is reliable or consistent or not. So to test the reliability of observed coefficient of correlation, we apply probable error, and it is abbreviated by PE. PE means probable error. So probable error, and in the bracket R is written. So probable error of R is equal to 0.6745. This is the numerical standard value you should keep in your mind. Okay, so you remember this one, and 1 minus R square upon under root n. R square is coefficient of correlation, n is number of pair of observation. Okay, so now limits of population correlation coefficient. Limits of population correlation coefficient means what is the limit? Maximum and minimum limits of the value of R. That is the limits of population correlation coefficient. Okay, so we always calculate R plus minus PER, probable error and R. And we interpret always, just you keep this one in your mind, if modulus R means positive value of R, okay, not negative value we consider. So R can take negative value also, but for the interpretation of this R, we always write this one modulus value. R, when R is less than probable error. When R is less than probable error, then there is no evidence of correlation. That correlation coefficient is not significant, not important. There is no correlation, we can say. If R is greater than 6 times PE, okay, 6 times PE, you multiply PE by 6. If it is greater than 6 times PE, that is significant. Okay, so this one you keep in your mind. Here one problem I am going to solve based on probable error. Yeah, the coefficient of correlation between 10 pairs of observation was to be 0.8. Test the significance of the result. Yeah, this is given. So we have formula here. At first, given. What given? Solution of this given is R. R is 0.8 and pairs of observation 10 given. Now we know that you write PE R is equal to 0.6745 1 minus R square upon under root n you write. And then you write 0.6745 1 minus R square is 1 minus, this is multiply, okay? 1 minus R square is 0.8 whole square, and under root n is under root 10. Now you simplify this one. This one we now simplify this one, and 1 minus, this is 0.64 and under root 10. Under root 10 is root of under 10 3.16. 3.162. This one. Now we subtract from 1. 1 minus 0.64, and then we divide into 0.6745 divided by 3.162. 3.162, that is 0.863. 0.x3, 0.8, okay, 0.8634. This is the value of probable error. Now, this value, now we interpret, okay, we interpret. And how we interpret? If this is 6 times P, this probable error is less than PE. If this is less than PE, R is less than PE. Yeah, 0.8. Okay, this value, whether this value correct or not, just we check. Okay. This one we check ourselves. I multiply last time 1 minus 0.64, that is 0.34. Okay, I think this value is wrong. This value is not correct. This value is wrong, I think. So you write this one 0.6745, and then you have, after subtraction, you get 0.36 and divided by 3.162. Okay, now we simplify. 0.6745 into 0.36 divided by 3.162. Previous value wrong, okay? 0.0767. This is the probable error. Now what is now you calculate, now you write, okay? Now 6 into P you calculate. For interpretation we need this one, 6 into P. So 6 into P PE means what? 0.0767. So what is the value? This one, 6 into 0.0767, that is 0.4602. 4602. And now this value is 6 times P. So 6 times P value, just you see here. Here, if R is greater than 6 times P, so what is the value of R? Value of R is 0.68. Therefore, R is greater than 6 times PE. So, what is our conclusion? R is highly significant. R is highly significant, we interpret, because it is greater than 6 times P. So in this way we interpret. Okay. Now sometimes you have asked also, find the limits of population correlation coefficient, also ask. Okay. So this formula you use. Lower limit R plus PE, you put the value of PE and you get upper limit, and lower limit R minus PE. Okay. In the case of lower limit, you subtract PE from R. In the case of upper limit, you add PE in R. So in this way, you can get lower limit and upper limit of population correlation coefficient. It is not difficult. So you remember this one formula, and after that 6 times PE. If value of R is greater than 6 times P, then it is highly significant. Otherwise, it is not significant. Okay, that's all for today. And this is very important. It will be asked in the examination. Okay, it may be asked. Thank you.